Hello and welcome, my name is Melissa and I'm here to showcase the Boids algorithm using the Unity game engine. So here's a quick introduction to how you would use the system. You can left click to spawn Boids and you can right click to add some collision objects. If you press the menu button, you can actually reduce their speed and you can increase their speed. So let's keep their speed to about 4, and the neighbor radius, you can also, here's a bunch of settings that you can change, but the most important ones is these toggle buttons over here, which is the rules to the Boids algorithm, which is separation, alignment, and cohesion. Now, perception is this neighbor radius. If we increase this perception, let's actually spawn a few Boids here, like this, and we increase the neighbor radius, which is their perception, you can see that they move towards one another because their perception is so large that they see every Boid in the system. If we decrease it to 0, you can see them scattering and moving the way they want to, because there is no perception, they don't see anything. So let's keep this to around about, let's keep it to 2. And if we uncheck separation, you can see they stop separating, so there's no, they're not separating. So if you actually check this again, then they start separating, and you can play around with the separation radius. If you increase it, they separate at a large scale, and if you decrease to 0, it's almost like separation is unchecked. So let's set this back to 1. If you decrease or uncheck alignment, you will see that they are not moving at the direction of their neighbors, because alignment is the average direction of the Boids movement. So all Boids in a Boid has a perception, and it will see the Boids in its perception and move to the average direction of the Boids in its perception. So if this is unchecked, they're still gonna be grouped, but they will move the way they want to. If we click that, you can see that they start moving in a direction or an average direction of the flock. If you uncheck cohesion, you will see that they scatter and separate because now they don't want to form groups anymore. And cohesion is just the average position of Boids. Okay, and if you uncheck everything, you will see that they are just going to start doing their own thing. They are still trying to avoid the sides. So eventually they will just move like this. And if we check everything again, you will see that they will start grouping again and move as a flock of birds. Okay, now we can talk about the code. So for the code section, here's the settings values that we've set in the UI, as well as the toggle values also set in the UI. Update settings method basically just updates these settings as they happen as you click them in the UI. So for the initial transform or the initial movement of a Boid when you spawn it, I opted for just moving that Boid into a upward direction. And here we're getting an array of colliders, which is a collider is just a box around a Boid, and then we are looping through each collider on a Boid, checking is this collider not, if it's not this collider, and is this collider a Boid? Because we have many colliders in the scene, we have walls, we have Boids, and we have other collision objects. So we're just checking, is it not this Boid, and is it in fact a Boid? Next, what we're doing is we're going to go ahead and check or get this neighbor direction, which is just our direction, our transform position minus the Boid's transform position. I'm also getting the magnitude of this neighbor direction to account for a more accurate force to be applied. So if it's further away the Boid in the flock, then we're not going to apply a more direct force than a Boid that is closer to us. Here we're just adding that separation, just checking the distance. If it's less than our separation distance, then we're going to add that separation to this avoiding heading value. Here is alignment and cohesion as well. We're getting the sum values of our average heading and the sum values of our average positions. Also getting the amount of Boids in our field of view or in our perception. I'll get back to this section just now. So if we have neighbors and there are neighbors around us, then we want to finally calculate that average heading as well as the average position. We'll also reset this vector, the steering force to 0 every single time, just to add a more accurate force. And then finally, we'll be adding this alignment force, cohesion force, and the avoidance heading force to steering force, and then applying that steering force to this transform, which is the direction that we are moving towards. And then finally, outside of this if statement, which is if we have neighbors, then we're also checking just to apply this force, this avoiding heading force. So what is the avoiding heading force? So the avoiding heading force is this section over here, which is if there is an obstacle ahead of us, meaning a wall or the other obstacle, then we want to try and avoid that obstacle as well. So we're just shooting out an array in the direction that we're heading. If we hit something, then avoid it.